Hello everyone, welcome back. And in this video we talk about the bit assignment instructions. The Siemens PLC has three basic assignment instructions: the equal or the assign instruction, and two other latching instructions called set and reset. Now, let's see how these instructions work and how they affect the status word register and the address in front of them. But first let's discuss what those three instructions have in common. The first thing is that all of them set both the first check bit and the OR bit back to 0 and therefore ending a logical block they came after. The second thing is that each of them doesn't change the value of the RLO. So we have RLO old equal to RLO new. This is actually why several assignments can come at the end of a logical block. As you can see here in our example, we used the three assignment instructions to end a single logical block. And finally, that they all reflect the new value of their address in the status bit for us to see it while monitoring the program. Now let's talk about the differences. These instructions differ in how they treat their address. First, we will talk about the equal instruction and we will explain its operation with this example. And first, let's assume that both of the inputs for this example are 1s. So M40.0 is 1 and M40.1 is also 1. And our results appear in M50.0, M50.1 and M50.2. And so let's start, and before our equal instruction. The first check bit and was 1, so it will be set to 0. The OR bit was 0, so it will remain 0. And the RLO was 1, so it will remain 1. Now what the equal instruction does is that it takes the previous value of the RLO, which was 1, and writes it to the current address, which is M50.0. And finally, that new value is also reflected in the status bit. So if we change one of the inputs to 0, the value of the RLO before the equal instruction becomes 0. And therefore, we get 0 in the address and in the status bit. So this is how the equal instruction works. Now let's discuss the set instruction. The set instruction is a latch-up instruction. This means that if the RLO before the instruction becomes 1, then it will change the value of the address and the status bit to 1. And if the value becomes 0, it doesn't change their values. Now let's look at our example. Initially, our inputs were 0s and the value of our set address was also 0. And let's first change both inputs to 1. And now the RLO before the set instruction was 1. And seeing that the set instruction sets the address and the status bit to 1. And if we change both our inputs back to 0, the RLO here will become 0, but the address remains 1, as you can see here and in the status bit. But do they remain set forever? The answer to that is yes, but only if no reset instruction with the same address comes next in your code. And now let's discuss the reset instruction. The reset instruction is basically the reverse of the set instruction. And it is a latch-down instruction. So if the RLO becomes 1 for once, it will reset the address. And the address will remain reset even if the RLO changes back to 0. And let's add to our previous example. So let's copy that. Change the addresses for the conditions. Change the assignment instruction to reset. Download the program. Let's assume that both our inputs here are 0. And let's set this reset address manually to 1. And as you can see here, the value is 1. Now let's change the RLO before the instruction to 1 by changing both of our conditions to 1. And as you can see, the value stored in that address becomes 0. Now changing the value of the RLO back to 0 will do nothing, as the address will remain 0. But does the address remain reset forever? The answer to that is yes. But only if no set instruction with the same address comes next in your code. So that sums up our discussion about the bit logic assignment instructions. And in the next video we will talk about how to implement the SR latch function, which is basically how you would use the set and reset instructions in a real application. So stay tuned and please like, comment and subscribe to the channel.